Alright, good day everyone. I want to welcome you back to uh, Math City once again. We have dealt with two questions out of the given assignment. We are now in question 3. Question 3 says that the position vectors of the points P, Q, and R relative to an origin are respectively given as P, vector Q, and R. So we are required to find the following vectors, that is from figure 1, figure 2, and figure 3 in terms of the vectors P, Q, and R. So without wasting time, let's just move into it. Now before this question will be properly answered, we need to understand or recall what we mean by position vector. And as discussed in class, a position vector represents a point relative to another point that is usually the origin. So as you can see, this point P, okay, actually is it runs from the origin and it's ended at this spot. You can see the line that I drew the line from here and it terminates at this point P. So this line that you're seeing, that blue line, represents a given vector. So that's vector P, small letter P that you are seeing here. This vector, this is what you have used to represent the line that you have here has been used to represent that. Then we can also have the for Q, that's another position vector starting from the origin. We also have for R. Okay, now what I'll do next is, before writing these vectors on this line, because I'm supposed to write it on the lines, that is P on this line, Q on this line, and R on this line, I would like to join this P to Q and Q to R, because I can see in the question that it is required. So let me just join that. I've done that with the purple line, that is P to Q. Then Q to R will also be joined, as you can see on your screen. So these two purple lines are not position vectors, they are displacement vectors, because the purple line, this one, it didn't start from the origin, and this one also not from the origin. So having said that, let's try to put these vectors appropriately on their lines. So the first one that we have, which is P, we placed on this line. Okay, we have P, then we have the next one is Q, and the next one is small letter R. And if you look at it very well, we are told to look for PQ. So the Roman figure 1, we have to obtain PQ. So for the vector moving from P to Q, in the diagram you will see very well that this is the required part, the one from P down to Q. Okay, the one from P down to Q, but it's not given. So I would rather go through the part that is given. I'm given this one as vector P, I've been given this one as Q, so I can also move from this point. Instead of moving straight, which is not known, I will move through the known part. I will move from P down to the origin, then reverse back and end it at Q. So I have done the same thing. Assuming I move from P to Q, I have done the same thing. So I can achieve the same goal moving from this part down, then back up, then I've ended in the same place. So if you recall what we did in for horizontal vector, this is what you have. So in that case, let me demonstrate that here with this one. So what I said is that we are moving from P. Alright, you can see my movement as it flows down to the origin, reverse back, and you go and you end at Q, which we will have moved directly from P to Q, but we didn't know that. We didn't know this part. So we moved through the given path down to our destination. So, but in that case, if you watch very well, I moved in the opposite direction. Okay, for P, I opposed this movement because the arrow is pointing this way, but my movement changed in this direction and I moved in this direction on the other line. But if you look very well, this arrow and this arrow are in agreement. They are facing the same side. Why this is facing the other side? So therefore, but I still have the same length for P, the same length for P, but opposite direction. So in that case, I will write this vector P to Q will be represented as negative P, because I moved in the opposite direction of P. I'll put it as negative. Because I moved in the same direction as Q, I'll put that as positive Q. And that is the end of the first one. Okay, so let's move to the next one. The next one, Navigo 2. Navigo 2 says we should obtain for PR. For PR. Okay, so for PR, let's go back to the diagram. All right, P to R, P moving from P straight to R. That is the requirement. But the path from P straight to R, directly to R, is not given to us. So we move in the other part. There is another way. There's another path you can take to still get to R. Okay, so I'll do that now. Right, so permit me to do that with this. Okay, so I'll move from here, from P to R now. Look at it, I am moving in the opposite direction. You check very well, of P again. I'm going to R now. I'm moving in agreement with that line. Let me go back again and do that. I am moving, the arrow for P is in this direction, but I'm moving in the opposite direction to it, which means my P will still carry negative again this time. And as I move in agreement with the arrow for R. So therefore, the answer I'll put here is simply negative P, because I move in the opposite direction, plus R, because my R will carry positive sign because I didn't move in the opposite direction. I moved in agreement with it. Okay, look at it very well. I moved here in this direction for R. Okay, now the last one, which is 1/3. Okay, 1/3. Number 3 says we should obtain QR. In that case, my QR is simply moving straight from Q to R. As you can see, we will move this time around in the opposite direction of Q for us to be able to get to R. Okay, because the direct path is not known. This direct path Q to R is not known, but I know this one as small letter Q, I know this one as small letter R. I can take that route and get to Q to R from Q. So let's take the movement now to be in this direction. Okay, I am moving in the opposite direction to Q, and I'm moving this way, and I'm heading it here. So in this case, I'll have let me do it very well. I am moving let me just use another thing to represent that. Okay, so we are moving in this direction. Okay, this direction, opposite to Q, but in the agreed direction compared to R. So in that case, I will have negative Q, okay, minus Q and plus R. This is how to answer the question. Okay, these are the things. So we have been able to represent the first vector P to Q, that's PQ, in terms of P and Q, the next one in terms of P and R, and the next one. So that's how to basically how to do that. And I hope if you see any similar question next time, you should be able to address that. I want to appreciate you for your time. Thank you for watching. I'll see you in the next video.